Let's work on part B now. So suppose there is a probability rho that an outsider will get the job and both workers will earn just the base salary in the second period. With the remaining probability, the promotion is going to be assigned as before. Now, what would be the level of effort that each worker will put in? Okay, again, because the worker decides his effort based on his own utility, we must maximize the expected utility of the guy. So the expected utility of one worker, what would that be in this scenario? Well, in the first period, he would still get his regular wage. That would be W. Now, what happens in the second period? Because now we have to deal with two probabilities. There's rho, and there's the remaining probability that we had in the previous video. Let's see how that works out, because it's actually more simple than it sounds. So we have the probability rho, right? We're working now with the second period. The probability rho that this worker will not get the bonus because someone else outside of the company is gonna get it. So with the probability rho, he's getting that just the regular wage. Just the regular wage. Let me just write the highlight. This is the probability that the outsider gets the bonus. So this is probability that the outsider gets the bonus. Now with the remaining probability, which is 1 minus rho, so with the probability of 1 minus rho, there is still the chance to get the bonus like before. And how did we get the bonus before? Well, remember, before we had these probabilities over here. P times W plus Z plus 1 minus P times W. This is how the probability was assigned, meaning that with the probability of 1 minus rho, we might get the bonus in this scenario. So we have to plot this into our function now. So let's do it. Am I going to remember this? Yes, I think yes. So with this probability, we might have the following. We might have, just a second, P times, so we would have P times W plus Z. We might get the bonus, and the remaining probability we might not get the bonus. Now we're closing the bracket because this is all we got. For the second period, right? We're closing the bracket over here, and we still have the cost of effort just like before. So minus 1 over 2 theta e to the power of 2. Let's write the highlights over here, what's happening. This is the remaining probability. This one is the remaining probability that we still have a chance of getting bonus as before. Chance of getting bonus as before. Although it sounds like too many probabilities, too many variables, right? Because we're multiplying this probability with a term that has a new probability P. Well, this P is going to cancel out with some stuff, and we're going to be left with less terms to work with. So we'll see how the math works out right now. The expected utility would be equal to the wage, right? We keep the wage over here. So we would have the wage plus, now we're working with this entire bracket. We would still have rho times W plus 1 minus rho. We keep 1 minus rho. And we're going to simplify things in the second bracket, because in the second bracket, and we could actually fast forward this a bit because we calculated this already in the previous video. When we work with this entire bracket, what are we left with? We're left with PZ plus W, because there is some stuff that cancels out, right, when we open the bracket. So to avoid this unnecessary step, we're just gonna take the result from here. PZ plus W. We would have P times Z plus W. So over here we would have, let me write like that, we would have P times Z plus W, yes, close the brackets, minus the cost of effort, minus 1 over 2, so minus 1 over 2 theta e to the power of 2. Okay, what can we do now? We could substitute the probability depending on the effort level, and then we can differentiate the entire expression with respect to the effort level. So we would have the following. We would have the expected utility of the guy equals to the wage is equal to the wage plus, and over here we would have rho times the wage plus 1 minus rho, 1 minus rho times the probability, and the probability was equal to 0.5 plus pi times the difference between the efforts levels. All of that multiplied with the bonus plus W. Let me change colors for the W. So plus the wage. Okay, we close all this bracket. Minus 1 over 2. So minus 1 over 2 theta e to the power of 2. Now we have everything depending on the effort level. We have it in all the terms possible. We can differentiate the expected utility of the first guy with respect to his own effort and make that equal to 0. Expected utility derivative with respect to effort level equal to 0. Let's start doing so. So from here, wage derivative, that's just a constant derivative, is going to be 0, plus rho times w, it's a constant that has nothing to do with the effort level. The derivative of that is equal to 0, plus, now in this term we must be careful. In this term we must be careful because we have something related with the effort level of the first guy. We see it over here. When we differentiate with respect to the effort level this entire term, what are we left with? We're left with the constants that are next to this term. And the constants next to this term is pi multiplied with z, and all this is multiplied also with 1 minus rho. So we have 1 minus rho times pi times z, and that would be it. When we do something, when we work with the second term, we have nothing after the derivative because it's the effort of the second worker, and we're differentiating with respect to the effort of the first worker. So there's no need to bother about that. W is a constant. Derivative with respect to the effort of the first guy is going to be just 0, so plus 0. And then finally we have the cost of effort, which is depending on our variable of interest. We're differentiating it, and we have 1 over 2 times theta. The effort derivative is going to be 2 times the effort. So 2 times the effort level equal to 0. Let's cancel out what we can over here. We have 2 and 2 go away. Now we have 1 minus rho times p times z. And let's take this term on the other side. Theta times e goes to the other side. So we have theta times e. Let's divide both sides by theta so that we have only the effort level that we're interested in. That's going to be 1 minus rho p times z divided by theta. Okay, now let's interpret this. When it comes to p and z, the interpretation is the same as we had in the previous video. When the dependence on the probability depending on the effort level is increasing, then it's worth putting in more effort. When the bonus is increasing, it's incentivizing us to work more. When the cost of effort is increasing, it's harder to put more effort, so it would decrease. This is what we care about the most now. What happens when rho goes up? So rho is the probability of the outsider getting the bonus. If this rho goes up, what is 1 minus rho? 1 minus a higher number. Well, this becomes smaller, right? This becomes smaller. 1 minus a higher number, it's gonna go down. So if this goes down, it means the effort level goes down as well. And what's the intuition here? Well, if there is a probability that is, if there is a high probability that someone else outside of the company might get the bonus, maybe that outsider, you know, is the nephew of this boss, and you know how things work sometimes, and he might get this bonus, then there is no incentive for the work to put in work. There is no incentive to work more. So that's why the effort level would go down. Hope this all makes sense. Next video we go to part C.